And we're continuing the conversation from the previous video about what sort of quadrilateral we have inside these two circles, where we used an outside circle and an inside circle to create a certain shape. Let's jump into the next part of it. So go back and watch the previous one, or maybe you like quick pause the video and catch what I wrote down. You have drawn 4 triangles. Did you notice that? Use these triangles to analyze the lengths of each side of the quadrilateral, and what did you notice? So first of all, let's actually name those 4 triangles. And I'm going to use maybe some color pencil, or I'm going to use, just like shade it in a certain way with a highlighter. I think color pencil will stand out enough though. So I'm going to use this color. Here's a triangle, AFB. And so triangle AFB right here has some information that we need. And I'm going to put that information down, that AFB. A is the center, right? It's that point in the middle. So triangle AFB. Then I'm going to color in another triangle. I'm going to color in AFC. AFC. So here's another triangle. I added the spikes. I added the boxes. I added the information, the highlighting. I wanted to make sure that what I'm using is consistent. And because I have colored it this color, AFC. So triangle AFC. And I'm naming them down here. I've drawn them. I should talk about them. Okay, let's keep going. So we have triangle that's AGC. So highlight, highlight, highlight. I'm putting the letters that I'm highlighting in a certain order intentionally. I don't want to just mix up the order of the 3 letters. I'm always starting at A because that's the center of the triangle. It's on the 90-degree angle. That I'm going AFB and I'm going AFC because I'm trying to map the sides that match. So then I can do the same thing down here. AGC, triangle AG, trying to match the sides that are, well, consistently in the same spot. What color should I use next? Let's go with this color, all right? AGC, so AGB this time. B is over here on the corner, so AGB. And so I want to comment on those triangles because I need to also bring home some information here, AGB, that these triangles are all congruent. And they're all congruent, meaning the same side, because they're created with 90-degree angles. Hope you can see it up in the top of the video there. My pencil is right here. And then the highlighted pink and yellow lines, those are diameters of circles. So therefore, diameters are split in half to make radii. And so this radius, AF, and this radius, AG, are the same. There is AF, AF, AG, AG in the names of those triangles. AB, AC, they're all the same as well. So AB, AC, they have matching sides, and a matching angle that's 90 degrees in between the shape. So we're going to say by SAS, side, angle, side. Now because the side, the angle, and the side, the side, angle, side match for all 4 triangles, then that means BF is congruent to FC, is congruent to CG, is congruent to GB. That's why I put the 3 spikes in the last video, because right here in part B, I'm saying what's happening. And the only reason that that works is because if you know that the 4 triangles are all the same, then after you know the triangles are the same, the pieces that we didn't talk about the outside edges when we used SAS, we used the inside sides. And the angle that's right here. But we didn't use the 3 lines, the 3 spikes. That's like an afterthought. And because it's an afterthought, we get to say that they are the same. And we're going to bring in an acronym, CPCTC. That needs a highlight because that goes way back to last trimester. It stands for corresponding parts of congruent triangles are congruent. All right? Determine the measure of each interior angle of the quadrilateral. All right, we're going to go ahead and jump into the next part right here. So I'm going to leave it like, boom, dropped it. What do you notice? All the sides are the same. This is what you're supposed to notice from part B. Now for part C. Determine the measure of each interior angle of the quadrilateral. So we're going to bring out the angulotron measuring device, the protractor. And we only need to measure one angle because this is a parallelogram. And since it's a parallelogram, the angles that are next to each other are 180 degrees. The angles that are across from each other are supplementary, which means congruent. Okay, I'm going to ignore the phone. Sorry, that's going to happen over here. I have to finish this video for you guys. And they can call back or they can walk by. Okay, so take the protractor, and I have a wide angle, bigger than 90 degrees. So I'm going to put the center of the protractor on one of the angles, the corner angle. I chose angle G. And then I'm going to tilt the angle, line it up here. And now if I look around the way over here, this pretty much looks like it lines up with 120 degrees. Maybe I'm off by a little bit because I'm human, but I can now identify the angle G, or specifically angle CGB. The measure of angle CGB is 120 degrees. Again, pay attention to the middle letter. So I wrote it right there. Using the picture from before, that's also the same as the measure of the angle across from it. So that's angle F, or better yet, angle BF. Pay attention to the middle letter, C. Now, without really needing to do a lot of measuring, do a little bit of like, what do we have right here, measuring. We can find the measure of angle B, and it's going to be 60 degrees. But I also should know that because what's 180 minus 120? 60. So that means that angle B, measure of angle GB, pay attention to the middle letter, is 60 degrees. The middle letter is the angle. And then across from angle B is angle C. I mean, you can look right up at your own circle page. So that means that the measure of angle C, well, I guess it's FCG, is also 60 degrees. Pay attention to the middle letter. That's a true statement about all parallelograms, rhombuses, squares, rectangles. Opposite angles are congruent, and adjacent angles, ones that form next to formed on the same side, those add up to 180 degrees. Okay, what names can you use to describe this quadrilateral? First off, it's not a square. The angles are not 90 degrees, but it is a rhombus. That is the most specific name, aka a diamond. But rhombus is a better name for it. If it's a rhombus, then it is a, I'm going to push it back here. If it's a rhombus, then it's also a parallelogram. Because in a parallelogram, opposite sides are parallel. If it's a parallelogram, you could say it's a special type of trapezoid. I don't really like that definition, but the book is going hard on that definition, so we'll use it. And then, of course, if it's a rhombus, if it's a parallelogram, that means it has 4 sides, 4 angles. So it must also be a quadrilateral. Right? It's a rhombus because, here we are, explaining your reasoning out loud. It's a rhombus because all sides are the same. It's a parallelogram because opposite sides are parallel. And it's a quadrilateral because, or a trapezoid. In a trapezoid, at least one pair of sides is parallel. Some people say in a trapezoid, only one pair of sides is parallel. And then in a quadrilateral, there are 4 sides. This is the rest of page 220. Thank you for watching this video. Thank you for skipping around through it and rewinding it to go through the end. If you watched it all the way in its entirety, why? But thanks. Be smart about how you're doing your math. Thank you so much for watching this video. Stick around for page 221, and we'll see you on the next one. Bye.